Hey everyone, and welcome back. Today we're going to be taking a deep dive into AI and game design.
Oh, cool.
Yeah, so this is a really cool paper from Nature.
Oh, wow.
So it's a pretty prestigious journal, and it's going to be all about how AI can help game developers come up with some new ideas and really kind of push the boundaries of what's possible in games.
Awesome.
So we'll look at how researchers are using actual gameplay data to train these models.
Wow.
Yeah, and we're also going to look into some of the challenges of, making AI that really supports human creativity.
Right, because we don't want just random stuff.
Yeah, exactly. Like we want it
Yeah.
to actually be useful for game developers.
Right.
So what really stood out to me in this paper is that they actually talked to real game developers.
Oh, that's interesting.
Yeah, so they actually interviewed like 27 creative professionals from a bunch of different game studios.
So like a good mix of people.
Yeah, so it's indie studios, AAA companies, and even people who specialize in accessibility.
Oh, wow. That's great.
Yeah, so they really got a good range of perspectives.
Yeah. And so what were they trying to find out from these interviews?
Well, they use something called a design probe.
Okay. A design probe?
Yeah, so basically it's like a simulation of potential AI tools.
Interesting.
And they presented these to the developers to kind of get their feedback.
So like get their thoughts on how AI could be integrated into their work.
Exactly. And it really helped to kind of push the conversation beyond, just the obvious applications.
I see. So it's about getting those deeper insights and understanding the real needs of developers.
Exactly.
So what were some of the things that the developers were talking about?
But one of the big things that came up was this need for balance.
Balance.
Yeah, so they were saying that AI-generated content needs to be both diverse and consistent.
I see what they mean.
Yeah, it's kind of like imagine an AI that designs furniture.
Okay. Yeah.
You would want it to come up with a variety of chairs, right?
Sure. For diversity.
Yeah, but they would also all need to be like structurally sound.
Right. And functional.
Yeah, exactly. So there's that balance between diversity and consistency.
Yeah, that makes sense.
And this really applies to games too.
Oh, absolutely. So, for example, diversity in a game could mean like different paths a player could take through a level.
Right.
But then consistency would mean making sure that those paths actually make sense within the game world.
Right. We don't want any characters walking through walls.
Exactly. Yeah, that would be a problem.
And there's actually a quote from the paper that I thought really highlighted this.
Oh, yeah. What is it?
It's from a VP of experience at an indie studio, and they were talking about their frustration with AI's current limitations.
Interesting.
They said the AI still isn't very good kind of generating, and then kind of following specific rules and mechanics, because it's inconsistent.
Yeah, I can definitely see why that would be frustrating.
Yeah, it shows that there's still a long way to go in terms of making AI that can truly support the creative process in game design.
Right. It's not just about generating random content. It needs to have that logic and consistency. So besides this need for balance, what other key insights did the researchers find from these interviews?
Well, another big one was this idea of iteration being super important in game design.
Iteration. Yeah.
So game developers, they don't usually create something perfect on the first try.
Right.
They're constantly experimenting and refining and tweaking their ideas.
Yeah, that makes sense. It's like any creative process, really.
Exactly. And so this need for iteration, it actually translates to a specific requirement for AI models.
Oh, okay. I'm curious. What is that?
It's called persistency.
Consistency.
Yeah.
I'm not quite sure I understand that. Can you explain?
Yeah. So basically, think about it this way. You're a designer, and you're using an AI to generate a game sequence.
Yeah.
Now, let's say you make a change to that sequence, like maybe you add an obstacle or you change the timing of an event.
Okay.
Persistency means that the AI needs to remember that change and then incorporate it into future iterations.
I see. So it can't just like discard the change and go back to the original.
Right,
Yeah.
exactly. It needs to be able to adapt and evolve along with the designer's vision.
Yeah, that makes a lot of sense.
And the game developers in the study, they really emphasize how important this is.
I bet.
There's a quote from a COO of an indie studio that I thought was really insightful.
Oh, yeah. What do they say?
They said, as game designers, we're not even conscious of the details where there are thousands of small decisions to be made. But we just know something's off and we tweak.
Yeah, that's really interesting. It really highlights how intuitive game design is.
Right. And it shows that AI needs to be able to support that intuitive flow.
It can't try to dictate the process.
Exactly. It needs to be a partner in the creative process.
A collaborator.
Yeah.
So how did the researchers address all these challenges?
Well, they actually developed an AI model called WHAM.
WHAM.
Yeah.
What does that stand for?
It stands for World and Human Action Model.
Okay, that makes sense.
And it's pretty amazing what it can do.
Oh, yeah. What can it do?
So basically, it can model the dynamics of a video game over time. So it predicts what a player would see on the screen, so the visuals,
Yeah.
and it also predicts the actions that the player would take with the controller.
Wow. So it's like playing the game in its own mind.
Yeah, kind of.
So how did they train WHAM to be able to do that?
So this is where it gets really interesting. So they trained it on a massive data set of actual human gameplay.
Oh, wow.
Yeah, so years and years of accumulated experience from real players.
So it's learning from the best.
Exactly.
That's amazing. What game did they use for the training data?
So they used data from a 3D 4v4 combat game called Bleeding Edge.
Bleeding Edge.
And get this, the data set spanned over 7 years of gameplay across multiple maps.
Wow, that is a lot of data.
Yeah, it's huge.
I can only imagine how much WHAM must have learned from all of that.
Right, and that's kind of the idea, is that by feeding it all this human gameplay, it'll start to understand the patterns, the strategies, even the subtle nuances that make a game really work.
That's fascinating.
So the big question is, did it work?
Right. Did WHAM actually live up to the expectations and the needs of game developers?
Exactly, and that's what we're going to find out in the next part of our deep dive.
Okay, I'm excited to hear more about this.
Yeah, we'll delve into the tests that they ran on RAM and the really cool results that they found.
Awesome. Can't wait.
All right, so stay tuned. Okay, so we left off with WHAM, this AI model that was trained on years of gameplay data.
Yeah, like a massive amount of data.
And we were going to see if it could actually deliver on the needs that those game developers were talking about.
Right. Those key requirements like consistency and diversity and persistency.
Exactly.
So did they just like give WHAM a pop quiz or something?
Well, not exactly.
But how did they actually test it?
So for consistency, remember, that's all about making sure the AI generates content that makes sense within the game world.
Right, it has to follow the rules.
Yeah. So to measure this, they use something called the Freshate video distance metric.
The what distance?
Freshate video distance.
Okay, that sounds complicated.
It's actually simpler than it sounds. So imagine you have two videos of gameplay.
Okay.
This metric compares them to see how similar they are, like both visually and in terms of the motion.
So like how closely they match up.
Exactly.
Yeah.
And the lower the score, the more similar they are.
Okay, so they were basically checking to see if WHAM could generate gameplay that looked and felt like it belonged in the actual game.
Right, exactly.
So like no characters teleporting around or walking through walls?
Yeah, exactly. So they gave WHAM a snippet of real gameplay as a starting point and then had it generate the next few seconds.
And then they compared that to what actually happened in the real game.
Right, using this Freshate video distance.
Drum roll, please.
And the results were pretty impressive.
Really?
WHAM was able to generate sequences that stayed consistent with the original gameplay, even for sequences up to 2 minutes long.
2 minutes? Wow, that's pretty long.
Yeah, it's a lot harder than just a few seconds.
Right, it's not just surface level patterns, it's really understanding the underlying mechanics of the game.
Exactly. And it really showed that WHAM was thinking like a human player.
Wow, that's really cool.
Okay, so WHAM passed the consistency test with flying colors, but what about diversity?
Right, because we don't want just the same repetitive actions over and over again.
Exactly. We need to see some creativity.
So how did they test for that?
Well, for diversity, they used a different metric called the Wasserstein distance.
Another distance.
I know, but this was pretty intuitive too.
Okay, good.
So think of it like measuring the difference between two sets of possibilities.
Okay.
In this case, they were comparing the actions taken by human players to the actions generated by RAM.
So like seeing if WHAM was just copying the most common moves or if
Oh.
it was coming up with its own unique stuff.
Exactly. And as WHAM trained on more data, this distance between its actions and those of human players actually decreased.
So it was getting better at being unpredictable,
Right. Less robotic.
more human-like.
Exactly. And this wasn't just reflected in the numbers. It was actually visually apparent in the gameplay.
Oh, wow. That's awesome. Give us some examples.
So in one example, they showed WHAM generating 3 different paths a player could take through a level.
Oh, cool.
And each path was unique. It showed different strategies and choices.
So not just the same predictable route every time.
Right, and there were other visual differences too, like characters using different weapons or wearing different costumes.
Oh, that's a nice touch.
Yeah, it really adds to the variety.
So HAM is like a brainstorming partner constantly coming up with new ideas.
Yeah, exactly.
Okay, so we've covered consistency and diversity. What about persistency, that last key requirement?
Ah, yes, persistency, the one all about collaboration.
Right. So how did they test WHAM's ability to work with human designers?
Well, they decided to throw Ham a curveball.
A curveball.
Yeah, they manually edited some of the game images and added in things that didn't belong there.
So like messing with its understanding of the game world?
Exactly, to see if it could adapt.
What kind of things did they add?
So they added extra characters, objects in weird places,
Oh,
even a game element called a vertical jump pad in a spot where it wouldn't normally appear.
so they were really trying to challenge it.
Yeah, and the results were pretty amazing. So when they showed WHAM just one edited image, it could keep that change in about 60% of the next generations.
Okay, it's not bad.
But get this, when they showed it 5 edited images in a row,
What happened?
its persistency rate jumped up to 85% or higher.
Wow, that's a huge improvement.
Yeah, so the more examples it saw, the better it got at understanding and integrating those changes.
So it really is learning and adapting to human input.
Exactly, and it shows the potential for real collaboration between AI and designers.
Not about AI taking over, but about AI empowering designers.
Exactly.
So all of this is super cool, but did they actually build anything with RAM, or was it just theoretical?
They actually did, they built a prototype tool called the WHAM demonstrator.
Ooh, a demonstrator.
Yeah.
What does it do?
So it basically gives designers a visual way to interact with WHAM.
So instead of typing in commands, they can actually see what's happening and make changes directly.
Exactly. They can choose a starting point,
Yeah.
see different possibilities generated by WHAM, and then either keep going or go back and tweak earlier choices.
So it's like having a brainstorming partner that's constantly generating new ideas and responding to your feedback.
Exactly.
This paper is really making me think differently about the role of AI in creative fields.
Me too. It's
But-
not about replacing human creativity. It's about amplifying it.
Yeah, like giving us new tools and new ways to express ourselves.
Yeah, it really feels like we're at the beginning of something big, doesn't it?
It does, and this paper makes me think we need to kind of change how we think about AI.
Oh, how so?
Well, instead of focusing on AI that can beat us at games or, write code, maybe we should focus on AI that can help us be more creative.
Yeah, so not replacing human creativity, but like working with it.
Exactly. It's like having a brainstorming partner that has superpowers.
Yeah, that's a great way to put it, and this research is a perfect example of that.
And it also shows that how we evaluate these AI models needs to change, too.
Oh, in what way?
Well, it's not just about speed and efficiency anymore.
Right.
It's about how while the AI can actually support the creative process, which is messy and unpredictable.
Yeah, it needs to be adaptable, responsive.
Right. And able to keep up with the human mind.
The researchers used the terms iterative practice and divergent thinking.
Yes, exactly.
And WHAM is proof that it's possible.
Right. Like it learned to model a really complex video game just from data.
Wow.
So imagine what could happen if we used this approach for other creative stuff.
Like what?
Well, think about AI that could help compose music or write poetry.
Or even design entire virtual worlds.
Exactly. And this isn't science fiction. This is the future we're moving towards.
That's incredible.
And to help move things along, the researchers have actually made the WHAM weights, the demonstrator, and a sample data set public.
Wow, so anyone can use them.
Yeah, anyone who's curious can explore the tech for themselves.
That's awesome. It's great that they're making it so accessible.
It really helps to democratize AI research and empower the next generation of innovators.
Well, this has been a truly mind-blowing deep dive.
It has.
We've seen how AI could completely change game design, boost human creativity, and even change how we collaborate.
It's been awesome talking about all this with you and our listeners.
It has, and I think we can all agree that we're just at the beginning of this journey.
Yeah, who knows what amazing creative things are just around the corner.
That's a great thought to leave our listeners with.
It is.
Keep exploring, keep questioning, and keep those creative sparks flying.
And we'll be back soon with another exciting paper.
See that?